All right, diving into another deep dive, and wow, you've really outdone yourself this time.
Uh-huh. Is that so?
Yeah, you sent a ton of stuff about some workshop in Singapore, all about open source tools for teaching physics.
Lots to dig into.
Looks like you're really interested in how technology is changing things up in the classroom, especially when it comes to open source stuff. We've got conference proceedings, slides from the workshop, even bios of the professors who ran the whole thing.
It's fascinating stuff. And what's really cool is this wasn't just some theoretical conference.
Yeah, what was it then?
Teachers were actually using these tools, getting their hands dirty. They even got guidance from the people who created the tools.
So, like, learning straight from the source.
Exactly.
That's awesome. Okay, so before we even get to the workshop itself, let's break down what these tools actually are.
Sure. Two of the main ones were Tracker and Open Source Physics, or OSP. Tracker is a video analysis tool.
So what can you use it to, like, analyze any video?
Pretty much, yeah. You could take a video, say, of a skateboarder doing a trick, and analyze the physics of their motion, frame by frame, things like velocity and acceleration.
No way. So instead of those simplified diagrams and textbooks, you could use real-world examples.
Exactly. And then there's OSP, which is a whole bunch of simulations and modeling tools. Imagine being able to actually visualize complex physics stuff, like particles in an electric field, right there on your computer.
Wow. It seems like these tools could make learning physics way more visual and hands-on.
Totally. And the fact they're open source is a game changer.
Okay, hold on. Let's unpack that a little. I get that open source means the software is free, but what's so special about that for education?
Well, it comes down to access and flexibility. Physics lab equipment can be super expensive, right? This limits opportunities for schools that don't have a lot of resources or even just students wanting to explore at home. Open source tools level the playing field.
It's like removing a paywall to high-quality physics education. That could make a huge difference for students who might never get to experience physics in a hands-on way.
Exactly. And the flexibility is huge too. Teachers can adapt and customize these tools to fit their needs and their students' learning styles. They can even help develop the software, suggest improvements, add features.
It's more like being part of a community than just using some software.
Yeah, I like that.
Speaking of community, let's talk about the people behind these tools, the masterminds who took their expertise all the way to Singapore for this workshop.
The big names here are Professor Douglas Brown, the creator of Tracker, and Professor Wolfgang Christian, who developed open source physics. They both have incredible backgrounds in physics and education.
Yeah, their bios were impressive. Publications, awards, workshops led. It's clear they're not just brilliant physicists, they're also really dedicated to making physics more accessible. Before this workshop, what were some of their most impactful contributions to the field?
Well, Professor Brown has been a pioneer in using digital video analysis in the classroom. His work has literally changed how physics is taught. He's also big on inquiry-based learning, encouraging students to come up with their own questions and design their own experiments.
So a big shift from just memorizing facts and solving textbook problems.
Huge shift. Professor Christian, on the other hand, has really focused on simulations, how they can make abstract physics concepts more tangible. OSP isn't just a collection of simulations. It's a whole framework for thinking about physics computationally.
So it's changing how we approach physics education, not just using tech as a supplement.
Exactly.
Now, from what I understand, these professors didn't just lecture in Singapore. They actually led hands-on workshops with teachers. Can you tell me a bit about how those workshops were structured and what they aimed to achieve?
From the slides, it looks like teachers got to really dive into using Tracker and easy JavaScript simulations, which is a part of OSP for building and customizing simulations.
So they weren't just passively listening. They were actually using the tools, learning how to incorporate them into their teaching.
That's right. They were downloading videos, analyzing them with Tracker, even building their own simulations. A real hands-on learning experience.
I can almost feel the energy in that room, a bunch of teachers excited to learn new ways to engage their students with physics.
And think about the collaborations that must have happened. Teachers from different schools with different backgrounds all coming together to learn from these experts and from each other.
That's powerful. But let's zoom out a bit. Beyond the specific tools and this particular workshop, what does this all tell us about the bigger picture of open source physics education?
I think it's a snapshot of a much larger trend in education, a move toward more accessible, adaptable, and collaborative learning.
So this workshop wasn't just about a specific software, it was about empowering teachers to be more creative and innovative with whatever tools they have.
Exactly. It's a shift in the whole mindset, a recognition that the best learning often happens when teachers and students can explore, experiment, and create together.
And that brings us to a very important question.
It makes you wonder about the impact, you know, like what happens when these teachers take what they've learned back to their own classrooms? Do these open source tools really change how physics is taught and learned?
It's a big question. It's one thing to have amazing tools, but using them effectively, actually weaving them into the curriculum, that's a whole other challenge.
One of the most exciting things is the potential to move away from just memorizing facts and towards a more inquiry-driven approach. Imagine students actively investigating, experimenting, actually problem-solving, instead of just passively soaking up information.
That sounds way more engaging, more empowering, too. But wouldn't teachers need to change how they teach? That's a big ask.
Absolutely. That's where good professional development is crucial. Just giving teachers tools isn't enough. They need guidance on how to use them well. And it sounds like this workshop in Singapore did a good job of that.
You mentioned earlier that the teachers were getting hands-on with Tracker and easy JavaScript simulations. Can you walk me through a typical workshop session? Like, what would that look like?
Let's say they're working with Tracker. Professor Brown might show a video, something simple like a bouncing ball, and then walk the teachers through how to import that video into Tracker, how to track the ball's movement frame by frame. Then they could use the software to analyze the velocity and acceleration.
So it's not just watching a demo, it's doing the analysis themselves, getting a feel for how the software works.
Exactly. It's interactive. They see how Tracker can take a simple video and turn it into this rich source of data for exploring physics.
Makes sense. What about the easy JavaScript simulations? How did those fit in?
Professor Christian might start with a pre-built simulation, like a pendulum. He'd explain how to change things like the pendulum's length or the initial angle. Then the teachers could experiment with the simulation, see how their changes affect the pendulum's motion.
So like a virtual physics lab where they can tweak things and get instant feedback?
Exactly. And since the code is open source, they could even look at the code itself, understand how the simulation is built, maybe even modify it to create their own versions.
So it goes beyond just using simulations to understanding how they work and even being able to tinker with them.
That's what's so cool about open source, that deeper level of engagement. It can be incredibly empowering for both teachers and students.
It's amazing how these tools can bridge the gap between theory and practice, you know? Students can see physics come to life in the simulations and then use Tracker to analyze those same concepts in real-world videos.
Couldn't agree more. It's one of the most exciting things about open source physics education. It's not just memorizing formulas, it's about developing a deep understanding of how things work.
It makes it so much more relevant, more engaging for students.
Totally. And that brings us back to the bigger picture. These tools aren't just about physics. They're part of a movement towards making education more accessible, more equitable, more engaging for everybody.
It's like democratizing knowledge, empowering learners around the world.
Exactly. And that workshop in Singapore, it's a perfect example of that. A story of collaboration, innovation, and how open source can change things.
We've been focusing on how these tools impact the classroom, but you sent over info about a public lecture the professors gave at the National University of Singapore, too. What do you think they might have focused on there? They weren't just talking to teachers, right?
Yeah, that's interesting. They had a broader audience then.
Yeah.
Students, other academics, maybe even policymakers.
So they were probably talking about the bigger implications of open source physics education.
Most likely. They
Yeah.
might have talked about the philosophy behind the open source movement, the importance of access, community-driven development, and how these tools could revolutionize education in all sorts of fields, not just physics.
It's like they were making the case for open source as a model for the future of education itself.
And with their experience, they're definitely the people to do it.
We've talked a lot about Professor Brown and Professor Christian's expertise, but what about them as people? What comes through in all this material that gives us a sense of who they are beyond just their credentials?
One thing that really stands out is their passion for teaching. They're not just academics focused on the theoretical side of physics. They clearly care deeply about making it accessible and exciting for others.
It's a special kind of dedication, isn't it? To not only be brilliant in your field, but to also be passionate about sharing that knowledge and inspiring the next generation.
Definitely. And their commitment to open source says a lot about their values. They believe in collaboration, sharing knowledge freely, and the idea that education shouldn't be just for the privileged. It should be a right for everyone.
It's inspiring to see that level of commitment, that idealism. It makes me wonder, what's their ultimate goal with all of this? What's the end game, so to speak?
It's more than just making physics more accessible, I think. They want people to become active learners, to think critically, to question things, and use their knowledge to solve real-world problems.
It's about fostering a culture of curiosity, innovation, a world where everyone feels empowered to explore and to contribute to knowledge.
Exactly. And open source is a powerful tool for getting there.
We've spent a lot of time talking about how these tools change the dynamics in the classroom, but there's another side to this. The stuff you sent included info about a public lecture the professors gave at the National University of Singapore. What do you think they might have focused on in that setting? They weren't just talking to teachers at that point, right?
Yeah, that's a good point. They had a wider audience then. Students, other academics, maybe even policymakers.
So they were probably talking about the bigger picture, the broader implications of open source in physics education.
It's likely they touched on the philosophy behind open source, the importance of accessibility, community-driven development, and how these tools could really shake things up in education, not just in physics, but in other fields too.
Almost like they were advocating for open source as a model for the future of education in general.
And given their experience and expertise, they're definitely the right people to make that case.
We've talked a lot about Professor Brown and Professor Christian's expertise, but what about them as people? What kind of picture do we get of who they are beyond just their credentials from all this material?
One thing that's really clear is their passion for teaching. It's obvious they're not just academics interested in the theoretical side of physics. They really care about making it accessible and exciting for others.
It's a special kind of dedication, to not only be brilliant in your field, but to also want to share that knowledge and inspire the next generation.
For sure. And their commitment to open source says a lot about their values, too. They believe in collaboration, sharing knowledge freely, and making sure education is a right, not just a privilege.
That kind of commitment, that idealism, it's really inspiring. Makes you wonder, what is it they ultimately hope to achieve with this work? What's the big goal?
I think it's bigger than just making physics easier to understand. They want to empower people to become active learners, to think for themselves, to question assumptions, and to use their knowledge to solve real problems in the world.
It's about building a culture of curiosity and innovation, where everyone feels empowered to explore the world around them and contribute to our collective knowledge.
You got it. And open source can play a huge role in making that happen.
Okay, so we've covered a lot of ground here, from the specifics of Tracker and Easy Java JavaScript simulations to the broader philosophy of open source education. But before we move on, let's actually dive deeper into these tools themselves. Let's start with Tracker. What makes it so valuable for physics education? What are some of its key features?
Well, one of the coolest things about Tracker is its ability to analyze movement in videos. You can track how something moves, frame by frame, and the software will calculate its position, velocity, and acceleration.
So you can take a video of, say, a basketball being shot or a car race and actually get precise data about the physics at play.
Precisely. And it's not just about watching. You can model, too. Create a mathematical model of the motion and then compare it to the data from the video.
So it's not just seeing what happens, but understanding why.
Right. That deeper level of analysis is what makes Tracker so great for learning physics. And you're not limited to just analyzing existing videos. Students can design their own experiments, film them, and then use Tracker to analyze their findings.
It encourages active investigation, not just passive observation.
Exactly, and Tracker's versatile. You can analyze all kinds of motion. Simple linear motion, projectile motion, circular motion, even rotational dynamics.
So it's something you can use throughout a physics curriculum, from basic concepts to more advanced topics.
Exactly. Now, when you switch gears to Easy Java JavaScript Simulations, or EjsS, you're looking at a whole different way to explore physics.
Right. Tracker's about analyzing real movement, while EjsS lets you create and play around with virtual models.
Spot on. With EjsS, you can build simulations of all sorts of physics phenomena. The motion of planets, how gases behave, the interaction of electric charges.
Instead of just reading about these things in a textbook, students get to see them in action and tinker with different variables.
Exactly. And EjsS is pretty user-friendly. You don't need to be a coding whiz to create simple simulations. They've got this drag-and-drop interface, so you can easily set parameters and run your simulations.
So even teachers and students with little coding experience can dive in.
Absolutely. And as they get more comfortable, they can dig into the code, customize simulations to explore more complex things.
So it grows with the learner.
Yes. And what's really powerful is combining Tracker and EjsS. Students can analyze real movement in Tracker and then build simulations in EjsS to model what they observed.
A great way to make that connection between theory and real-world application.
Couldn't agree more. It helps students see how abstract physics principles actually work in the real world, which makes learning way more meaningful and engaging.
They're not just learning about physics, they're becoming little physicists themselves.
You got it. And that's what open source physics education is all about, giving everyone the power to explore, understand, and contribute to the world of physics.
It's a pretty powerful vision. Speaking of vision, let's shift gears a little and talk about how using open source tools affects how physics is taught and learned. The pedagogical implications, I guess you could say.
Okay, sure. Well, I think one of the biggest changes is the shift from passive learning to active learning. Traditional physics teaching often involves a lot of lectures, memorizing facts, and formulas.
It can feel really disconnected from the real world and how science actually works.
Exactly. Open source tools like Tracker and EjsS let students take charge of their learning. They can ask their own questions, come up with their own experiments, collect and analyze data, and come to their own conclusions.
So it's about developing critical thinking skills and problem-solving abilities, not just memorizing the right answers.
You got it. And that active approach can lead to a much deeper, more meaningful understanding of physics.
It's not just about knowing the right answer. It's about knowing how to ask the right questions and how to find your own answers.
That's it. And another important shift is towards more collaborative learning. Open source tools often create a sense of community where people share what they're doing, help each other out, and build on each other's ideas.
So instead of the traditional model of students competing against each other, it creates a more collaborative and supportive learning environment.
Exactly. And that's really beneficial for students.
Great.
It helps them develop communication and teamwork skills and feel like they belong to a community of learners.
It's about creating a culture of shared learning where everyone feels valued and has something to contribute.
Precisely. And that kind of culture is essential for fostering innovation and pushing the boundaries of knowledge.
We've covered so much in this deep dive, from the specifics of Tracker and EjsS to the broader impacts of open source physics education. But before we wrap up, I want to bring it back to the listener for a minute. Imagine you're a student who's just starting to learn about physics. What would you say to spark their interest and show them why physics is so cool and important?
That's a good one. I think the key is to help them see how physics connects to their everyday lives. It's not just abstract concepts and formulas. It's about understanding how the world works, from the smallest atoms to the vast galaxies.
It's literally the science of everything.
Exactly. And there are so many mind-blowing things that physics can explain. Why is the sky blue? How do airplanes fly? Why does a guitar string make a sound?
These are questions that everyone wonders about, and physics has the answers.
Exactly. And tools like Tracker and EjsS can help make those connections. They let students see physics in action, experiment, and discover for themselves how the laws of physics shape the world around them.
It makes physics more tangible, more relatable, and maybe even fun.
Definitely. Once students start seeing the world through the lens of physics, it opens up a whole new way of understanding and appreciating the beauty and wonder of everything around them.
It's like getting a superpower, the ability to see the hidden workings of the universe.
I like that. I think that's the ultimate goal of physics education, to help students develop that sense of wonder and give them the knowledge and skills to explore further.
Well said. So you've given this a lot of thought, the future of physics education. What are some of the most exciting things you see on the horizon?
One thing I'm super excited about is virtual reality and augmented reality being used more in physics education. Imagine being able to walk around inside an atom or explore the surface of Mars in a simulation.
That would take immersive learning to a whole new level.
Right. These technologies could make learning even more engaging and accessible, especially for students who learn best through hands-on experiences.
It's like tearing down the walls of the classroom and bringing the universe right to them.
Exactly. And another thing I'm keeping an eye on is the role of artificial intelligence in education. AI can personalize feedback for students, pinpoint where they're struggling, and suggest resources to help them improve.
It's like having a personal tutor for every student.
It's not about replacing teachers, though. It's about giving them more tools, freeing up their time so they can focus on things that only humans can do. Mentoring, inspiring, fostering creativity.
Using technology to create the best possible learning environment for each student.
Absolutely. And I think open source will be a big part of all this. Because it's collaborative and transparent, it's perfect for developing and sharing these innovative tools.
It's like a global community of educators and developers all working together to shape the future of physics education.
That's the idea. And it's an exciting time to be involved in this field.
I agree. Well, we've really covered a lot in this deep dive. The features of Tracker and EjsS, the impact of open source physics education on how we teach and learn, and we even peeked into what the future might hold.
It's been great talking about all this.
Me too. And I think our listener is going to come away from this with a much better understanding of how these tools are shaping the future of physics education.
I hope so. It's something I'm really passionate about, and I love sharing that passion with others.
Your passion definitely comes through. And I want to thank you for taking the time to share your expertise with us today.
It's been my pleasure.
Okay, before we go, one last thought for our listener to chew on. We've talked about how beneficial open source tools are for students, but what about for teachers? How can these tools empower educators and make their jobs more rewarding?
That's a great question to end on. I think open source tools give teachers some real advantages. The biggest one is access to this huge library of resources that can enrich their teaching and make their classrooms more engaging.
It's like having a treasure chest of materials at their disposal, ready to be adapted and tailored to their students.
You got it. And because a lot of these resources are developed and shared by other teachers, they offer valuable insights and inspiration.
It's like a global network of colleagues to collaborate with and learn from.
Exactly. And beyond the resources themselves, open source tools empower teachers by giving them more control over how they teach. They're not limited to using prepackaged materials. They can create their own lessons and activities tailored to their students' needs and interests.
It's about becoming a creator, not just a consumer, owning their teaching style and approach.
Exactly. That can be incredibly rewarding for teachers. It lets them be more creative, innovative, and responsive to their students.
And when teachers are engaged and empowered, everyone wins.
Absolutely. It's a win-win. So to all the teachers listening, I encourage you to explore open source education. You might be amazed by what you find, and you might just rekindle your passion for teaching and create some truly amazing learning experiences for your students.
That's a great message to end on. So until next time, keep exploring, keep asking questions, and keep diving deep into the world of knowledge.
Yeah, it's amazing to see how these tools can really turn the classroom into, well, a different kind of learning space.
It really is. And it's cool how this workshop in Singapore wasn't just about the technical stuff, like here's how the software works. They actually put a lot of emphasis on how to use these tools well, how to really integrate them into teaching.
Yeah, it's not enough to just hand teachers new software, right?
Yeah.
You got to show them how to use it effectively, how to make it work in their classrooms. So what do you think were some of the big pedagogical takeaways from the workshop?
From what I've seen, one of the biggest things seems to be the focus on student-centered learning. These open source tools aren't just about making things easier for teachers, they're about giving students more control over their own learning.
Makes sense. It's not just about swapping a textbook for a simulation. It's about changing the whole approach, right?
Exactly. Instead of just listening and memorizing, students are actually investigating, experimenting, figuring things out for themselves.
Yeah, like becoming more active in the learning process.
Right. Which reminds me, I read something by Professor Brown where he talked about moving away from the sage on the stage model of teaching. The teacher standing at the front lecturing. He was advocating for a more collaborative approach, like a guide on the side.
I like that analogy. And these tools, Tracker and OSP, they can really help with that shift. With Tracker, students can analyze real-world stuff, and OSP gives them the power to build and manipulate models, test their ideas, see how things change in real time.
It's like giving them the tools to be scientists, not just students of science.
Exactly. And that hands-on inquiry-based approach is what the Singapore workshop really highlighted. The teachers weren't just learning about the software, they were using it, designing experiments, analyzing data, building their own simulations. That kind of firsthand experience is crucial if they're going to bring that same energy and engagement back to their own classrooms.
It sounds like it was as much about a new mindset as it was about new software, a new way of thinking about what physics education could be.
Yeah, I think that's the really exciting part. It's about moving away from just memorizing formulas and solving problems by rote. It's about a more creative, more exploratory, and ultimately more meaningful way of learning physics.
And realizing that learning doesn't happen in isolation. It's about working together, sharing, and building on each other's ideas, which is, when you think about it, the heart of the open source philosophy, right?
Absolutely. Open source is all about making knowledge accessible to everyone and encouraging collaboration and innovation. It's a perfect fit with progressive education.
It's about creating a learning environment where everyone feels like they can explore, experiment, and contribute. This has got me thinking. We've been talking about open source in the context of physics, but these ideas, this approach, it can apply to any subject, right? Whether it's history, literature, art. There are tons of open source resources out there that can help you learn anything.
You're so right. Open source isn't bound to any one field. It's a way of thinking about knowledge and how we learn that can be applied across the board. So, to everyone listening, go explore. See what open source learning has to offer, no matter what you're passionate about. You might be surprised at what you discover and how it changes the way you learn and think.
Absolutely. Well, we've certainly covered a lot in this deep dive. The powerful tools like Tracker and OSP, the inspiring work of educators like Professors Brown and Christian. We've talked about the big picture impact of this movement and even got a glimpse of what the future might hold for open source physics education.
It's been a fantastic conversation.
It really has, and I have a feeling our listener is going to come away with a much deeper understanding of how open source is shaping the future of physics education.
I hope so. It's a topic that's near and dear to my heart, and I always enjoy sharing that passion with others.
Well, your passion has certainly come through loud and clear. Thank you so much for joining me today and sharing your expertise. It's been a real pleasure.
The pleasure was all mine.
And to our listener, thanks for joining us on this deep dive. We'll see you next time. Keep exploring, keep questioning, and keep on learning.